Hello everyone, my name is Rohit Singhal and we were discussing about the topic hydrocarbons. In the previous classes, I have briefly touched about the basic structures and properties of alkenes and alkynes. We have talked about, we have broadly first classified hydrocarbons into saturated and unsaturated hydrocarbons, and then we discussed about the further classifications in alkanes, alkenes and alkynes. I have also briefly discussed about the nomenclature of the hydrocarbons, that how we nomenclature the compounds. Now, in this class we will further discuss about the nomenclature and the isomerism of the hydrocarbons. So, let us discuss first about the nomenclature. I have already discussed the 2 points in the previous classes, that first, while naming any hydrocarbon, two things have to be keep in mind. First thing, identify the number of carbons, and second, identify which hydrocarbon is present. For example, I have told if the number of carbon is 1, it will be called as meth, 2 eth, 3 prop, and so on. Similarly, if the hydrocarbon is alkane, the name will end with ane. If it will be alkene, the name will be ending with in, and alkyne, then it will end by ine. So, these were the basic rules I have already taught about how we can give the names to the different members of the hydrocarbons. But the thing is, till now I have only discussed by the molecular formula, or if there is a straight chain present, there can be some branches, then the name of that hydrocarbon can change. So, how will that take place, that we will discuss in today's class. So, for example, let us take an example of C4H10. So, what I have till now taught is about the straight chain, means there is only one CH2, CH2, CH3. This is going to be a straight linear chain. So, this is how we will nomenclature the hydrocarbons on the basis of this previous 2 points, that there are total of 4 number of carbons. So, 4 number of carbons means bute, and it is an alkane. All the well, there is not C double bond C, there is no C triple bond C, that means it is an alkane, and the name will end by ane, butane. So, that is how I have told till now. For example, let us take there can also be one other possibility with the same molecular formula. For example, there is CH3, CH2, CH3, CH3. Now, take this example here. If I will check the molecular formula of this, how many carbons? 1, 2, 3, 4. 4 carbons. How many hydrogens? 3, 5, 7, 10. So, there are 10 hydrogens. So, the molecular formula for this is also same, but this is not butane. Name will be different. You must have studied in the previous classes also how we name. So, first for this type of thing, see the longest chain, the longest carbon chain. So, longest carbon chain. So, how we will see this? 1, 2, 3, or we can also say 1, 2, 3. Okay, let's use another pen to better tell you guys. 1, 2, 3. Either way you can name it. the product will be, the name will be same, the structure will be same, the nomenclature process will be same. So, what is it? This is a 3 carbon chain. Now, 3 carbon chain we call this propane, right? If it's an alkane, right? Propane, but propane we know is this also. So, what's the difference between this and this? There is a substituent on this carbon. Okay, there will be one hydrogen and CH to complete the valency. Okay, there is one substituent CH3 is there. So, how we will say it's on 2 position, two position pe. So, there is a substituent, which substituent? Methyl group. So, we will write 2 position, its methyl group is attached. So, 2 methyl propane. So, this will be the complete name of the structure. Okay. So, we have discussed this example C4H10, one can be this CH3, CH2, CH2, CH3, its name is butane. The another is CH3, CH2, CH, CH3 and CH3, and its name is 2-methyl butane. Now, if you notice in this thing the molecular structure, the molecular formula. So, what is the common between these two? Molecular formula is same, right? That is C4H10. The molecular formula is same. What's the difference? Structure is different. And this difference in structure. So, the molecular formula of both these compounds are same, but the structures are different, and the structure difference in structure leads to the difference in the physical properties of this structure of this compound. For example, the boiling point, the melting point, or the other physical properties, or the chemical properties, how they are going to react with other substituents. This will change, and the only reason because of it, the chemical structure they are, but the formula is same, structure is different. So, these type of compounds which have same molecular formula, okay, the structures or the compounds having same molecular formula but different structure that what they are leading towards, that lead towards the difference in their physical and chemical properties. Such compounds or such molecules are called isomers, or to be better classified into isomers is these are the constitutional isomers. Constitutional isomers. Okay. So, what are the physical properties? These are different. Their physical properties, we can say there is a boiling point difference. For example, the boiling point of butane is 273 Kelvin, whereas the boiling point of 2-methyl butane it's around 260 Kelvin. Okay. So, we can clearly see the boiling point of this butane and 2-methyl butane is different. Similarly, we take another example, it is C5H12. So, what are the possible structures this can have? So, the possible structures are, okay, one is simple straight chain CH3, 5 carbon chain CH3, CH2, 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 CH3, 1, 2, 1, 2, 3, 4, 5. So, it is a pentane, right. It is an alkane starting with pent, it is an alkane, that is why ending with N. And sometimes what we do nomenclature, it is a normal pentane, right, a normal straight chain. So, you may see in a lot of books there is there is an N written in front of this. This N means normal straight chain. That means, or we can say no branching present, no branching present. Okay. What the another example can be? This is the first thing. Second, let us start with the substituent. Okay, CH3 C. Let us take one substituent here, CH3. 1, 2. How many valencies remain? 2 valency, right? Okay, so one will be this. Let us say H, one H is there, CH, CH2, CH3. How many carbons are there? 1, 2, 3, 4, 5. What will be the longest chain? So, this nomenclature will not be N pentane, right? So, how do we name it? There can be 1, 2, 3, 4, or it can also be 1, 2, 3, 4, whatever. Both ways, the chain is of 4 carbons. Straight chain जो है वो straight chain is of 4 carbons in both the way. So, it does not create any difference whether we go this side or whether we go like this or we go like this. So, there is no difference. Okay. So, what is the name of this one will be? There is a substituent on position number 2, and what is the substituent? It is called methyl, right. So, 2 methyl. How many chains? How many carbons are there in the longest chain? 4 carbon. That means butane. So, it is 2 methyl butane. What can be the third one? Let us try the substituent on the other position. Okay. If I will do this CH2, CH, CH3, many of you guys can think of this structure is a possible one that can form a different isomer. Once we have substituted on the second position, now we are substituting on the third position. So, but this will not be the case. Both these structures are same. How these are same? Let us see. Okay, let us name it. We will name it 1, 2, 3, 4. So, you guys say ki yeah, it is 3 methyl butane, but no, it is not correct actually. The numbering starts actually from where the substituent is the closer. So, the numbering is done such that the substituent attached is closer. Here the substituent is coming on the third position, and if it name like if we name it from the right to left direction. So, what will be 1, 2, 3, 4. What will be the case in that? What will be the name of the structure in that case? It will be 2 methyl butane. So, that is why I am saying both this you might think that the position we have attached the methyl group, one is on second position, one is on third position, and they have the two different structures, 2 methyl butane and 3 methyl butane. No, this is not correct. We have to do the numbering, we have to do the numbering in such a way that the substituent attached to the longest carbon chain, whatever the longest straight chain there is present, the substituent attached is the nearest to the carbon chain. Okay. So, these two actually are the both the same compounds, not two methyl, both are 2 methyl butanes. If the structures are same, the name, the formula, everything will be same. If the molecular formula is same, but the structure is different, then the name will also be different, and then they will form the isomers, and the process in this process is called isomerism. So, we think of any other structure? Yes, there is one other structure also possible. So, okay, so till now we have discussed a straight chain. What two structures we have discussed? CH3, CH2, CH2, CH3. Another one is CH3, CH2, okay, CH3, CH2, CH3. Okay. So, another possibility is there. This is N pentane. Okay. This was 2 methyl pentane. What is the third possibility? CH3. We know there can be substituents only on the second position, because second position starting from here or from the left side or right side, it will not matter much. Okay, there are 5 carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, now there is 4. Okay, so we know that the substituent on this position and substituent on this position are same. Okay, so how we can do that? Okay, so yeah, what the other structure can be? So there we have attached one substituent, right, CH3. So what we have done in the 2 methyl pentane, we have attached a hydrogen here, and then we attach CH2. Instead, what we can do, let's remove this hydrogen and attach one carbon. This hydrogen can also be replaced by one CH3, right? So this can be structured. So how many carbons we have already used? 4 carbons. So it will be CH3. Now see, 1, 2, 3, 4, 5. So what will be the longest chain? 1, 2, 3. So now there are 2 substituents. So 2 substituents means 2, and both the substituents are on the carbon number 2. So what will be the name? 2. What are the substituents? There are 2 methyl groups attached. So 2 dimethyl. Dimethyl means 2 methyl groups are attached. 2 methyl groups on same carbon, and there it will be pentane. So this is 2 dimethyl pentane, or 2 methyl pentane. So it is 2 dimethyl pentane. So this will be the structure. So our structure C5HN, the molecular formula was C5H12. Sorry, C5H12 have 3 possible structures. One is N pentane, another is 2 methyl pentane, and the third one is 2 dimethyl pentane. Not pentane, sorry, it will be sorry. I have written 2 methyl. It's butane, because there are 4 carbons are in the longest chain, and it will be propane. Okay, so this will be the structures. Okay, so in this class we have discussed about we further go ahead in the nomenclature. We discussed about the isomers, what is the isomerism, and how the isomers are different. What are the isomers? How the structure changes. How the molecular formula is same, but the structure is different. That leads to the different in the physical or chemical properties of the compounds. In the next classes, we will further discuss about the isomerism, how alkene isomerism take place, how the alkyne isomerism take place. So till now, thank you so much.